Well, it's been a while, and I have something new from Aliexpress. This is the CG1000Q power inverter, 1000 watts, 24 volts in, and 220 volts out. I chose for the 24 volt version because I have a homemade power station suitcase with 69 18650 batteries, modular, and I will make a video of this thing someday. It's charging now from the power outlet. Yes, I'm sitting on the ground because I have a lot more space here than on my desk. Okay, but to the point. So this is a 24 volts power station, and that's the reason why I chose for the 24 volt version of the power inverter. True sine power inverter in this case. I have a European socket here, some kind of, and let's test it out. Before I do that, what's a true sine power inverter? Well, I have another power inverter here, and this is a modified sine wave power inverter. This is the cheap one, and yeah, this one is 12 volts in. So I have a buck converter here that goes from the power station to the buck converter 24 volts, and the output of the buck converter is about 13.5-14 volts. So that's what I'm putting on the input here. This is a oscilloscope. This is not a very expensive one because I don't trust this equipment with my expensive one. More expensive. It's not very expensive, but expensive enough to be careful about these kind of measurements. So I got my cheap one to show you the waveform. So when I'm turning this on, you can see a modified waveform. There are all kinds of corners. It's a bit bumpy. And yeah, it's a square form, more of a square form than a waveform. This is not very linear. When you connect a ventilator or some kind of motor on this thing, you will hear a hum quite hard. So yeah, it's not very good for a lot of equipment to give this kind of waveform as power supply. So that's why I wanted to try a true wave power supply. Let's turn this off. Now what I'm going to do is I'm going to yeah, these wires are not very safe, but don't I'm a professional. Don't try this at home. Yeah, you know the story. Okay, I'm going to give it a pause, and I will connect the shit on for for the Aliexpress version. Well, to be honest, this label claims to deliver 300 watts continuously. I've tested this out, and it's more of a 300 watts peak. And if you look at the sizes from this one and this one, I don't really trust this label. I don't think this will deliver 1000 watts. But hey, if it's working, if it's delivering 100 watts, then I'm happy. It was only 40 euros. No, I'm mistaken. This was about 20 euros. This was not 40 euros. This was about 20 euros, I guess. Okay, let's connect it and do also a power test. Okay, I'm back. It's not really safe, but hey, it's only a test. Okay, this is the new Aliexpress power inverter, true sine power inverter. This is the power station again. The 24 volt goes directly into the inverter. You can see that it's not completely 24 volts. It's still charging up until it's fully charged when it's about 25 volts. So it's not it's about the battery percent is not very accurate. It's saying that it's 100%, but that's not correct. Okay, so 24 volts on the input. On the output we have a little power meter. This is the oscilloscope. This wire goes to this little boy, and on the output we have this little boy. So we can consume very accurate some wattage. Okay, let's power it up. It's going very slow. It's powered up. I have to configure my oscilloscope. One moment. Okay, that was not configuring, it was just a crappy wiring, my fault. So I'm turning it on. Very slow. It will give the true sine wave, and that looks a lot better than the inverter that I just connected. That's good. Okay, it's saying it's 228 volts, and we are consuming about nothing. These are the costs, the volts, amps. Is that wattage? I can't read it. What the heck? One moment. Okay, that's better. So it's on. You can see the sine wave. You can see that I'm pulling 11 watts right now. So let's consume a little more. This may kill the inverter, but let's just try it out. 30 watts. 76, 90. Oh, there's a ventilator. 130 watts right now. Can you see the sine wave? It's still pretty. Is it still? The voltage is also still the same. 228 volts with 130 watts. Let's boost it a little more. $200 watts. 200 watts and still a nice sine wave. How do you like that? Okay. Now it's complaining about the input voltage. This is more than 300 watts. Still 221 volts, but the power station is now 20 volts, so that's why it's going to beep. I'm impressed. I'm very impressed. More than 300 watts, and it's surviving. It doesn't blow up, and it has still a nice sine wave. I don't know how long this will last before it blows up, but I'm impressed. Wow. Shall we boost it a little more? Okay, here we go. Until it stops. 360 watts. $211 volts and a nice looking sine wave. $400 watts. Nice looking sine wave. 204 volts. Oh, it's complaining. It's complaining because the voltage is under. Oh, it stops. Did you saw that? More than 400 watts with no problem. The only problem was the voltage on the input because my power station wasn't charged enough. I'm very impressed. I'm very impressed.